Hi there. All right, so you're watching this video because you missed class this week, or maybe you didn't understand the lesson this week, so I'm going to go over what we covered. We studied lesson 10. We started lesson 10. And lesson 10 is on a topic called radiation. Right, so please go ahead and pause the video and bring your notebook and be ready to take notes about lesson 10, radiation. We started our discussion by looking at this symbol right here, which maybe you have seen this symbol before. Where do you remember seeing it? A lot of girls were saying that they saw it in the hospital. To be specific, some of them were saying they saw it in the X-ray room, which is exactly right. This symbol means radiation. It's a symbol of danger. It means don't enter this room because there is radiation. All right, so maybe you've seen this symbol before, but you're wondering what is the meaning of radiation and where radiation comes from. So if I have an atom, and this is the nucleus. This is not just any nucleus, but this is what we call an unstable nucleus, or an unhappy nucleus. Okay, so this is an unstable nucleus. Okay, and a nucleus that is unstable is really unhappy. So this nucleus is going to release something. This something is called radiation. Radiation comes out of an unhappy nucleus, or we want to say unstable. Now, when an unstable nucleus releases radiation, it's going to become, what do you think? Stable. It's going to become stable. So an unstable nucleus is going to become stable. So please copy this definition into your notebook. When a nucleus releases radiation, it's called radioactive decay. Please copy this. It is a process that occurs when an unstable nucleus changes into a stable nucleus by emitting radiation. Emitting means taking out or releasing. All right, let's keep going. So if I have this unstable nucleus, this unhappy nucleus or unstable nucleus, and it's going to release radiation. Boom, boom, boom. There are 3 kinds of radiation that can be released. The first kind is called alpha, the second kind is called beta, and the third kind is called gamma. So there are 3 kinds of radiation that can be released from the nucleus. Please write in your notebook 3 kinds of radiation: alpha, beta, gamma. All right? Now, you have to know some information about all 3. Let's begin with alpha. Alpha radiation has a symbol like this. You see here where it says symbol? It has a symbol like this. Here, this is alpha. Or sometimes we do like this, He42. All right, this is the symbol for alpha radiation. The charge of alpha is +2. The mass of alpha is 4. The description of alpha is a helium nucleus. Okay, you can see here in the symbol, this is the symbol of helium. So alpha is not a helium atom, but it's just the helium nucleus. All right, please make sure you can copy this into your notebook. All right, then it says in the last column, penetrating power. This one, penetrating power. It says penetrating of power of alpha is low. Can be stopped by paper. This means if you have a piece of paper, let's pretend this is paper. If I have a piece of paper and I have alpha particles coming, they cannot pass the paper. Okay, let's say these are alpha particles. They cannot pass the paper because they are too big. Okay, alpha particles are too big. They cannot pass paper. Beta. Beta particles are having this symbol, B, or E0 minus 1. Okay, sorry, not like this. It's E0 minus 1. This is the symbol of the beta particle. The charge of the beta particle is -1. The mass of the beta particle is 0 AMU. A beta particle is actually an electron. Yes, it's a high-speed electron that's coming out of the nucleus. Now, the penetrating power of beta particle is moderate. Moderate means medium. It can be stopped by thick metal foil. So, if I have a piece of aluminum foil like this is a piece of aluminum foil like the one you have in your kitchen, and there are some beta particles coming, the beta particles cannot pass the foil. You can stop them using foil. The last type of radiation that you'll be studying is gamma. Gamma radiation is the most dangerous. Gamma radiation is like the radiation in an X-ray. Okay? The symbol for the gamma radiation is like this. It's like a funny shaped Y. Gamma radiation has a charge, 0. Gamma radiation has a mass, 0. Gamma radiation is called a photon. Okay? A photon is just energy. It's not a particle. It's not actually something. It's just energy. Okay? You can also write that gamma radiation is electromagnetic waves. Electromagnetic waves. Okay? It's like this. It's energy. The penetrating power of gamma radiation is very high. This means that gamma radiation can pass inside of many things. You can stop it with thick lead or concrete. So if I have a big piece of lead or concrete, like cement, okay, concrete is like cement, then the gamma radiation cannot go inside. You see that? You can stop it. So the gamma radiation is the most penetrating because it's very small. All right, take a minute to pause the video and make notes about the characteristics of some types of radiation. All right, take a look at this picture. This picture talks about the penetrating power of radioactive emissions. This purple ball right here is an unstable nucleus. Remember, we said unstable nucleus are unhappy. So unstable nucleus will release radiation, alpha, beta, gamma. Look at the first thing we have here, the paper. Then we have aluminum foil, then we have lead. See the alpha. It's traveling and it stops with the paper. It cannot pass the paper. The beta, it can pass the paper, but it cannot pass the aluminum foil. The gamma can pass the paper, pass the aluminum, but gets stopped by the lead. Even some gamma can pass the lead because gamma is highly penetrating. Now let's look at how radiation behaves in an electric field. You can see here that there's a positive plate and here there's a negative plate, like in a battery. This is the radioactive source. This is where radiation is being emitted. This radiation is alpha, beta, and gamma. Now, one of the radiations goes up, one of them goes down, and one of them stays straight. Which one do you think is alpha, beta, or gamma? The alpha radiation has a +2 charge, so positive will go to the negative. So positive alpha will travel down. Beta radiation has a negative charge. So beta radiation will travel up because this is where the positive plate is, and positive and negative attract. Gamma radiation has no charge. So the gamma radiation will stay traveling in a straight line. All right, so now that you've had some practice and you've taken notes, you can go ahead and open this quizzes game using this code and you can have some more practice about radiation.